Hi, welcome back to the channel, and today let's learn ISIS basic functions and configurations. So it's important to understand what ISIS is. So ISIS is intermediate system to intermediate system, which is an IBGP protocol that runs within an autonomous system. So by the end of this topic, you should be able to understand ISIS and also be in a position to configure ISIS comfortably. So we're going to look at our networking requirement today. So this is IS configuration experiment. In the introduction part, the objectives are, upon completion of this task, you'll be able to perform basic ISIS functions, configurations, change the ISIS designated intermediate system priority, change the ISIS network type, import external rows to ISIS, change the ISIS interface cost, configure ISIS route leaking. So those are the concepts we are going to implement in this practical. This is how the topology will look like. Then in the background, a customer's network use ISIS as an IBGP. Router 4 and router 5 are level 2 routers and run in area 49.002. Router 1, router 2 and router 3 belong to area 49.00001. Router 1 is a level 1 router, whereas router 2 and router 3 are level 1-2 routers. Router 5 imports the external route 192.168.1.0. So that is the networking requirement. So that is the practical we are going to implement. So when we get to this our topology, as usual, what we start with is we are going to configure the interface IP addresses on the routers. These switches are just acting as the bridge. We won't configure anything on the switches. They are allowing just the packets to pass through to the other routers. So we enter into our first router and we configure the IP address. So the name we are going to give it, this is router 1. On router 1, we have got gigabit 1, so interface gig 0/0/1. IP address, we give it IP address of 10.0.123.1/24. After that, we create a loopback interfaces. We were told that it's going to use the loopback of according to the router number. So we're going to use 10.0.x, where x here represents the router number. So on router 1, we quit and enter interface loopback, loopback 0. IP address will be, we'll use IP address of 10.0.1.1 /32. Then we go to second router here. On our second router, we also configure the IP address. We're going to give it the name of router 2. Then enter interface gig 1, interface gig 0/0/1. IP address is 10.0.123.2/24. Then gig 2 that connects to the router on the external area will be gig 2. The IP address of 10.0.24.2 and it is a /24. We create also the loopback interface for that router. So interface loopback 0. IP address, we give it IP address of 10.0.2.2 because it is router number 2, and it's a /32. Do the same to router number 3 here. Give it a name. This is router number 3. On router number 3, we enter two interfaces, that is gig 1 and gig 2. So interface gig 0/0/1. IP address. IP address is 10.0.123.3. /24. Then we enter for gig 2. Gig 2 has an IP address of 10.0.34.3/24. So IP address of 10.0.34.3, it's /24. Then we create the loopback for that router. So interface loopback 0. IP address for that loopback is 10.0.3.3, and it's /32. We quit and go to the next router. We are now on router number 4. UTM. The name is router number 4. Create the interfaces. So it has got 3 physical interfaces and 1 loopback interface. So interface gig 0/0/1. IP address is 10.0.45.4/24. That is the interface that connect to router number 5. Then gig 2 that connect to router number 2. IP address is 10.0.24.4/24. Then gig 3 that connects to router number 3. IP address of 10.0.34.4 and /24. We quit and create the loopback interface. So interface loopback interface loopback interface loopback 0. Its IP address is 10.0.4.4/32. Then next we go to router number 5. It's our last router. So UTM give it the name of router number 5. So it has got one interface. So interface gig 0, that is a physical interface, 0/0/3. And IP address for that interface is 10.0 .45 dot 5 slash 24. Then you quit and create the interface loopback. So interface loopback 0, IP address is 10.0.5.5 slash 32. Let's test the connectivity between router 1 and router number 2. So we ping 10.0.123.2. The packets are going successfully. Now, after we configure the interface IP addresses, the next thing now we're going to implement is now configuring the ISIS now. So when you look at our router 1 is on ISIS area of 49.0.00.1, and router 4 and router 5 are on AS 49.0.0.2. So you have also been labeled here that router 1 is a level 1 router, and router 2 is a level 2 router, and router 3 are also level 3 router. As you all know that level 1 router is an intra-area router. It cannot advertise routes to the external areas, while router 2 and router 3 here, they are level 1 and level 2 router, level 1 and level 2 router, and routers on this other area are level 2 router, that is router 4 and router number 5. With the router number 2, it is an inter-area, and it can advertise the external routes into other areas. So those are the things that are important also to understand while you are doing ISIS configurations. So we're going straight away to configure ISIS. So we start with the router here. This is our router number 1. Create ISIS process ID of 1. The network here, we are going to use the device ID of, we are going to use the router number. So ISIS, this is a level 1 router. Then we create the network entity. Network entity will be 49.001.00.00.00. Service ID 1.00. After creating that, we quit and enter the interfaces, and we enable the ISS on the interface, both the physical interface and the logical interface. So interface gig 0/0/1 IS enable IS number 1, and enter interface loopback 0. And we tell also to enable ISIS on that interface. You go this do the same to router number 2. We quit, and on router number 2 here, ISIS process is number 1, and this is a level 1/2 router. That is, it acts as the ABR router that is used in OSPF. It's important to understand the difference between ISIS and OSPF. So in ISIS, ABR is known as the level 1 or level 2 router that advertise the border routes into a different area. So on ISIS, because it is a level 1/2 router, we won't need to enable it on that is ISIS process, because by default Huawei uses ISIS level 1/2 routers. So We're just going to configure the network entity of 49.00.00.00.001 and the net is 00. We quit and enable it on the interfaces. That goes 2 interfaces and 1 logical interfaces. So interface gig 0/0/1 ISIS, we enable ISS number 1. Enter gig 2, we also enable the ISS on that interface. We quit and enter interface loopback 0, which is our logical interface. We enable ISIS also on that loopback interface. Next, sorry guys, there's something here on our ISIS. We configured the wrong network ID. So ISIS 1, display this. To display this, you see here it is .1, but we are supposed to use .2 because this is a router number. Router number 2. Control C, copy, then you undo. We edit that, we put it .2. So next, now we are going now to router number 5, router number 3 I mean. ISIS here, process number 1, and network entity will be 49.00.00.003 because this is router number 3, that is 0.0. We quit and we enable it on the interfaces. So interface 0/0/1 ISIS, enable process number 1. Also do to gig 2. We enable ISIS process number 1 also. Then we quit and enter loopback interface. Interface loopback 0. Enable ISIS on that loopback interface. And now router number 4. Quit and create ISIS 1 network entity of 49.0.0.0.000.004 because this is router number 400. We tell it this is a level 2 router, so ISIS level is level 2 router. Quit and enable it on the interfaces. So interface gig 0/0/1 ISIS enable number 1, gig 2 the same, gig 3 you also enable process number 1. Then you quit and enter interface loopback 0. So interface loopback 0 also enable ISIS on that loopback interface. Finally, we are on router number 5. We quit and create the ISIS process number 1. Network entity here is 10.0.0.0.0.0.0.5.00, and it's ISIS level 2. Display this. You can see the information that we've configured. You quit and enable it on the interface. So interface gig 0/0/3, enable ISIS, enable process number 1, quit and enter for the loopback. So interface loopback 0, enable ISIS that interface, and you quit. So we're going to check ISIS configuration. So display ISIS peer, so display file router number 1, so quit and display ISIS peer. And display ISIS peer, according to the command output, router number 1 has been established. As you can see here, it's level number 1 with it's been established with router number 2 and router number 3. Also do the same on router number 4. Display ISIS here. You can see the peer has been established with the level 2 router has been established with the router number 2, router number 3, and also router number 5. As you can see from the interfaces, gig 1, gig 2, and gig 3 respectively. So I think with the ICIS basic configuration we are done. We are now going to continue. The next is now we're going to can you also display the ISIS route before we proceed? So on router number 4, quit and display ISIS route. You can see all the information for the ISIS have been configured here. So the next we are now going to configure now the DIS priority, that is the designated intermediate system priority on gig 001 on router number 1, so that router number 1 is elected as the DIS among router number 1, 2, and 3 that are on the same broadcast network. So router 1, 2, 3, we are going to enable DIS on router number 1's interface. DIS is just a designated intermediate system. So in a broadcast network, ISIS needs to elect DIS from all routers. DIS are used to create and update pseudonodes and generate link state protocol data units, that LSSP, which are the same as the LSS for OSPFs, or pseudonode to describe available network devices. So on our router 1 here, First of all, let's display ISIS interface. When you display ISIS interface here, you can see the part of designated. We are told no. So meaning that the designated has not been enabled on the interface. So we enter interface gig 0/0/1, then ISIS designated priority. Let's see the range for the priority. So it is from 0 to 127. Now that's where the difference comes, because with OSPF areas, priority of 0 cannot be used to elect DR router, but with ISIS, priority of 0 is valid when electing a DIS router. So here the range varies from 0 to 127. So the higher the value, the higher the priority, the higher the preference of being selected as the router, this DIS router. So here we are going to use the higher priority of 127 on that interfaces. So it's important to understand the difference between ISIS and also the OSPF. With ISIS, let's say this router that we've selected as the designated intermediate system, when a new router that has a higher priority joins the network, it will be elected as the DIS. This is different from the OSPF, where with OSPF, however, the higher the priority, when a new device with the higher priority joins the network, it will not be added as the DR router. It will wait until the DR goes down, is when a new election will be triggered for election of the backup designated router after the backup takes the role of designated router. So in case you find that the priorities are the same, we are going to use the highest MAC address for that interfaces. But for this case, I will configure a priority of 127. Now let's display the ISIS interface. When you display the ISIS interface, you can see now here in the part of designated, we have got yes, it's telling you that the designated priority have been enabled. I'm going to quit, and after that we are going to import external routes on router number 5 here. We were told that router number 5 connects to loopback number 1. Loopback number 1 here. Let me name it here. Loopback 1. IP address was 192.168.1.1/32. So we are going to import it as this is a direct route. We are going to import it into ISIS. So interface loopback 1. Interface loopback 1. We're going to give it IP address of 192.168.1.1/32. Then we quit. So then you enter ISIS process number 1. Then we import route direct. After import the route direct, we are going to display the ISIS route. So display ISIS route. When you display ISIS route, you can see the routes that have been learned through ISIS up here. Then when you come down, there are also a route that has been learned through direct, so that is 192, the route that will configure, that is 192.168.1.1. It is D here, the type here you see D, and from the explanation here they say D means direct and I means ISIS, S means static. So here is a direct route. Let's go to route number 4 and display the ISIS route to route number that direct route. So display ISIS route to 192.168.1.1. When you display that, you can see the destination, and also the interface cost is 10, and the outbound interface is gig 0/0/1. The next stop being 10.0.45.5. With that done, we are going to proceed with other configurations. So according to the preceding command output, the ISIS routing table on router number 1 does not contain the route to. So let's come to router number 1. So display ISIS route. When you display the ISIS, you see we can't find the route to 192.168.1.1. So because level 1, 2 routers do not link level 2 routes to the level 1 routers by default. So with that, router number 1 does not have the imported external route to route 192.168.1.1 until we configure what is called route linking. That will configure is in our last step. So we are going to change the ISIS cost. So we are going to change it on router number. We are going to change it on router number 4. So we go to router number 4. Display ISIS route to 10.0.1.1. If you look at that, you can see we have got 2 routes towards that network, that is with the next hop being 10.0.2.4.2 and 10.0.34.3. so these 2 routes are load balancing. But here we are going to configure different costs so that it selects the route with the lower cost. So while on that router, we enter interface gig 3. So gig 3 is the interface that connects to the router number 3. So interface gig 0/0/3. Give it ISIS cost of 15. Then again display now the ISIS route towards that network. Now we have got only one route with one destination, that is 10.0.24.2. that is the router on router number, that is router number 2. So it will select the upper route towards router number 1. So after that, I think we again, the next thing we should also configure, we quit So to ensure security, we're going to configure ISIS authentication. So to ensure network security, ISIS authentication encrypts ISIS packets by adding authentication in the field to packets. So this one we are going to configure it on all the interfaces that connect to the routers. So on router number 1, here, to enter interface gig 1 0/0/1, interface gig 0/0/1, ISIS authentication mode. Here we're going to use MD5, then we use the password as Huawei. So this one we are going to configuring ISIS based on interface based. So we have got area authentication, interface authentication, and also the domain authentication, routing domain authentication. So in this case we are using the interface authentication. So on that router we configured the authentication to safeguard our ISIS LSP packets. So we are going to router number 2. So with router number 2, both the physical interfaces. So interface gig 0/0/1, ISIS authentication. Here we are using MD5 with the password being Huawei. Enter gig 2. You give it the password, we quit, and also we go to router number 3. On router number 3, the interface gig 0/0/1, gig 0/0/1, and ISIS authentication here with MD5. Password is Huawei. Gig 2, do the same. We are now on router number 4. We are configuring authentication router number 4. So interface gig 0/0/1, ISIS authentication here is MD5, password being Huawei. Gig 2, same. Gig 3, give it the same password, and we are now on router number 5. Quit and enter interface gig 0/0/3, ISIS authentication here is MD5, password being Huawei. So after configuring ISIS authentication, in our last step now we are going to configure ISIS leaking routes. So let's get into our router number 1 and see if router number 1 can learn the external routes on a different area. So display IP routing table 10.0.5 5.5. You see, it can only advertise. You can only see the default route here, that is 0.0.0.0 with the two next hops, that is 10.0.123.3 and 10.0.123.2. So here is where we are going to configure now. Configure the ISIS route leaking. Normally, level 1 routers manage routes in level 1 areas. All level 2 and level 1-2 routers form a contiguous backbone area. So level 1, 2 and level 2, they are the routers that are found in backbone area, while level 1 is only found in an internet area. So level 1 is in a non-backbone area. So level 1 areas can only connect to a backbone area and cannot connect to other external area. Like for instance here, level 1 has connected to router number 1.2, and router number 1.2 is the one that has connected to the other external area. So level 1.2 router encapsulate land level 1 routing information into a level 2 LSP and floods the level 2 LSP to other level 2 and level 1.2 routers. That's having said that, level 1.2 and level 2 routers know routing information about the entire ISIS routing domain. So that is where we are going to configure leaking routes to reduce the size of routing tables. So to reduce the size of routing tables, level 1.2 routers advertise the default route. So the default route that we see here, that is 0.0.0. So because level 1 router does not know the routing information of other routes outside the local area, that is the area here. In this local area 49001, this level 1 router doesn't know the routes beyond that area. So we are going to configure leaking routes so that routes on area 4900 where router 2 and where router number 4 and router number 5 belongs, the routes can be imported into ISIS area 49001. So we do that while we are on router number 3. Wait, so ISIS 1 on ISIS 1, then we import ISIS level 2 into level 1. After that, come now and see if it has taken effect. So now we display ISIS route to that. When I display ISIS route to 10.0.255, you can now see it has generated that external route. So meaning that we've imported level 2 routes into our level 1 route through the import ISIS level 2 into ISIS level 1. So that is the point of implementation. That is what we are going to configure in this practical. So I think we are done, and because we configured the leaking routes, we configure the designated router, and also we configure the basic ISIS functions. So with that we are set, and let's meet in other practicals in our next classes.